All right, so we're going to talk about some special cases today as well as review some of our... All right, so remember this is a compound inequality, and that's what we've been talking about in the last few videos, is compound and absolute value. So remember I can solve this one of two ways. I can either leave it as it is and remember to solve to all parts, or I can split it into two, and I will do both again today. So we always start by undoing addition subtraction. Okay, -3 minus 1 is a -4. Less than, I still have the 2x, that canceled out, less than 4. Divide both sides by 2, and I get -2 is less than x, which is less than 2. Okay, and on the graph, this would look like, I would have an open dot at -2, and x is actually greater than a -2, right? So I'm going to start by, I'd be shading to the right. Then at 2, oops, sorry, wrong number. At 2, I would have an open circle, and I'd be shading to the left because it's x is less than 2. Now remember with an and, because this is an and, we're looking for the numbers that are overlapping. So in this case, it'd be, any number between -2 and 2. Now remember, I can split this into two equations. So I could get -3 is less than 2x plus 1, and 2x plus 1 is less than 5. And I would still solve them the same way. That is a terrible 5. Let me fix that. There we go. So we still end up with the same thing. Now, remember with our absolute value inequalities, we always isolate that absolute value first. Now, because this 4 is adding, right? Or there's an addition sign, we know it's in between it, it's not multiplying. Okay, it is a positive 4, so we are going to subtract it. That still leaves me with absolute value of 2x plus 9 is greater than or equal to, okay, 11 minus 4 is 7. Okay, so now I've got my absolute value isolated, so I can set up my 2. I get 2x plus 9 is greater than or equal to 7. Greater, so this is an OR inequality, and 2x plus 9 is less than or equal to -7. So now I have two inequalities. So -9 on both sides. I'm going to get 2x is greater than or equal to 7 minus 9 is a -2. And divide both sides by 2. We get x is greater than or equal to -1, or -9. And a -7 minus 9 is a -16. So 2x is less than or equal to a -16. Divide both sides by 2. And x is less than or equal to -8. All right, so I've got -8 over here, -1 here. Okay. All right, so I'm going to graph these two. So x is greater than a -1, greater than or equal to. Well, we know this is a closed circle because it's equal to. And since x is greater than, we're going to shade to the right. We want all the numbers that are to the right. Okay, x is less than a -8, so we have a closed circle at -8. And we are going to shade to the left because x is less than. Now, is this acceptable? It's an OR, right? So we're just looking for one of them to be true. Okay. All right, so let's look at one now. That's going to be a special case. All right, so I've got another or compound inequality here. Okay, so the first thing I'm gonna do is I'm gonna solve these both out. So I can distribute, right? So I get 8x plus 2 is less than 26. Let me write that 8 just a little better. There we go. Now, subtract 2, and I get 8x is less than 24. Divide by 8, divide by 8, and I get x is less than 3. Or, all right, so I've got variables on both sides here, right? Well, let's get them on the same side to make it easier on ourselves. So I'm going to move the 5 since it's got something else with it. The 3 does not. So I'm going to add 5. Negative 3 plus 5 is 2x greater than a negative 10. Divide both sides by 2. And I get x is greater than a negative 5. All right, so on my number line, what does this look like? Okay, I've got 0. So x is less than 3, right? So I've got an open circle. And since it's less than, we're going to be shading to the left. I'm going to change colors for this one. So x is greater than a negative 5. So again, I have an open circle. I'm going to do this up a little bit so we can kind of see it. But this x is greater, so I'm going to the right. Now, this is an or, right? This is not an and. So we don't need the overlapping section, do we? Remember, with an or, we only need one of the inequalities to be true. So if I picked 4, okay, let's say I picked 4. Well, 4 is not less than 3, is it? But 4 is greater than a negative 5. So that's true. If I picked a negative 6 is less than 3, right? But it's not greater than negative 5. What about 0? Well, 0 is less than 3, and 0 is greater than a negative 5. Remember, we can have both true. So this is what we call all real numbers. We've come across this before. Okay, so that means that no matter what I plug in for x, I'm going to get a true statement out. All right, so let's look at another one. So again, this is an absolute value, which again, remember, is like a compound. So isolate your absolute value first. I'm going to add 2 to both sides, and I get x plus 3 in the absolute value is less than negative 10 plus 2, which is a negative 8. So now I can set up my 2. I get x plus 3 is less than a negative 8. And x plus 3 is greater than a positive 8. Now, when we did absolute value equations, remember, it couldn't equal a negative. That is not the case for inequalities. And I'm going to show you why here in a second. Now, why did I pick and? Well, it's less than, right? Less than. Remember, we talked about that on Friday, in the last video. All right, so I'm going to minus 3. So we get x is less than a negative 11. And, okay, minus 3 over here. X is greater than 5. So we get x is less than a negative 11 and x is greater than 5. So this is an and, so both have to be true. Okay, so we're going to kind of look at this, and I know my number line may not have enough space here, so we're just going to put these at the end. Negative 10, negative 11. Okay, so we've got an open circle at negative 11, and I'm shading to the left because it's less than. open circle at 5, and I'm shading to the right because it's greater than. Well, here's the problem, isn't it? This is an and compound inequality, or an and absolute value. Shouldn't I be having an overlapping section? I should. So no matter what I plug in for these, am I going to have both of these true? Well, no. If I plug in something that's true for this one, right, x less than negative 11, it's not going to be true for x greater than 5. So this is what we call no solution. Okay, and we're going to kind of look at what these look like in a couple more again. All right, so I've got another and compound inequality. So I'm going to go ahead and distribute and solve these. So we get 2x plus 10 is greater than 20, and I'm going to go ahead and solve this one. Well, we'll come back to that one in a second. Minus 10 on both sides, and I get 2x is greater than 10. Divide by 2, and I get x is greater than 5. So, let me erase that so I have room to work. I'm going to move the 3x because it's on, which gives me 5x is less than negative 10. So we get x is less than negative 2. So we got x is greater than 5 and x is less than negative 2. So we're going to have an open circle at 5. Oops. And I'm shading to the right. Open circle at negative 2 and shading to the left. This is an and. Do my graphs overlap? No. So it's a no solution. And remember when we talked previously, a no solutions graph is just nothing on the line, number line, because we have nothing that will be a solution. All right, and our final one, we've got 3x, the absolute value of 3x is greater than a negative 12. So my absolute value is already isolated, so I can take 3x greater than a negative 12, greater, it's an or, and 3x less than 12. So remember, with absolute values, the negative being greater than or less than a negative does not determine whether we can work it out or not. Okay, it will determine whether it is a no solution or an all real numbers. All right, so I'm going to divide both sides by 3, and I get x is greater than 4, or, sorry, negative 4 there. X is less than 4. So again, when we look at this graph, we get 0. We've got an open circle at negative 4, shading to the right. And we've got an open circle at 4, shading to the left. So, because it's an or, I'm not stopping at the 2 dots. I don't need only the overlapping. So all right, and that is it for this video.